Okay, this is Professor Jimenez. Now we're going to see how to design a water vending controller where we have here several conditions. In this case, port C will be using 6 bits to read the time for the serving time required for the minimum coin. In this case is a nickel. So because we have 6 bits, 2 to the 6 is 63 or 64. So we have 64 different times starting from 0. And the maximum time will be 63 seconds for a nickel, which is very a big time. In practical machines, water vending machines, this time for a nickel will be around 10 to 15 seconds. RC7 will be the output to control a relay, a water bulb relay, which will control a water pump. Most of these pumps are centrifugal. And we have a display on port A, input, the outputs RA0 to RA5. And we also have the coins to detect will be through these 3 inputs, RB4, RB5, RB6 for nickels, dimes, and quarters. And RB7 will be the push button to serve water when it is pressed and providing a low logic. In standard logic will be a high. In the initial time will be in logic high. So this timer for water vending machine accepts these 3 coins, and it'll be designed in such a way that when the user deposits the first coin, he can decide if he or she wants to serve that amount of water or time. In this design, we're not waiting for to complete a price to serve 1 gallon. No, the user can even deposit a dime and it'll receive that amount of water. And if he deposits a nickel, he will receive that amount of water. The maximum time will be, the maximum coin or amount of money accepted will be $1.50 to avoid failures, because in case one of these sensors starts failing, it'll not increase the register or the variable that keeps counting the deposited coins, so it will not fail. But anyway, at the end, the user will have, the student will have to add self-diagnosis to read the initial status to verify that everything is okay before starting to operate. Okay, once these conditions are established, now we proceed to write the code. So the code will start, as it says right here, for the programmable timer for the vending machine. The port C is set with a time equal to the minimum coin deposited. So a nickel is equal to 1 times the program time, a dime is equal to 2 times the program time, and a quarter is equal to 5 times. Okay, so our minimum unit in this case is a nickel. And right here we configure the ports, port C, RC0 to RC5 set as inputs, RC6 and RC7 set as outputs. Port C is digital, RB4 and through RB7 are inputs, they are digital. Port A is an output, which is driving the liquid crystal display. And it's an alphanumeric display. And port A is set as digital, and the option reg is used to enable pull-up resistors on port A. So right here we enable those resistors required. So you can see all those details. And we use the OSCONOSUN at 4 megahertz, and we declare the variables we'll be using. And we have to define where the data port required. In this case, port A will be driving right here is port A, will be driving liquid crystal display. So we will see in another lesson more details about the how to set up the LCD. Okay, so we start here with this code, and notice that we have here the first variable. I'm going to increase this a little bit, that way you can see it better. And okay, so we start here with this label. RPT is my first label. I am clearing all ports. I'm clearing the variable called total, which detects the total amount of money, the total amount of coins in this case. So I first start reading the three types of coins in these three conditional instructions. So if port bid .4, so if RP4 is equal to 1, then go to nickel, to this label. If data is not true, it'll read this one. So go to dime. If this one is detected, then go to quarter, so, and go back to coin. So the microcontroller is continuously looping here, waiting for one of these three types of coins on the optical sensors. Okay, it'll stay there as long as there's no coin detected. Once a coin is detected, it'll jump to that location. So you can see here now that if a nickel is detected, so the total, it'll be total plus 1, because a nickel for us is 1 unit. So right here I have, as you can see here, I have a counter with the variable total. So I have here 5 times this variable, so 5, because a quarter is equal to 5 times, a dime is equal to 2 times. So depending on where it falls, the condition, it'll get the total. So if it is a nickel, it'll be equal to 1. If it is a dime, it'll perform this one plus this one, so it's 2 times. If it is a quarter, it'll fall right here, and it'll perform 5 times this instruction, so it'll be 5 times the total count. So once I detect, or we detect the first coin, the LCD will display on the first row. This will clear and the display, and will display the $sign, and it'll display the decimal value of the variable total. So you will see that value, that amount, of that total of coins deposited. You will see it in the screen. Okay, and as a matter of fact, you will see the number of times. Okay, not exactly the amount of money, but we can change that. We can change that, of course. And right here, the LCD out. This is C0 is for the second line. In the second line, the user will see the message push button. This means that once the first coin is detected, the user might decide if he wants to serve or he wants to deposit more coins. No problem. The code will do this. The code will be here, and it'll perform 20 loops of 100. 20 loops, and you can see here next side. So if we want to do this 20 seconds, so we have to do this 1000 here. So 20 seconds, so we have to establish here 20. Or we can establish 30, 40 seconds, anytime that you might find good. So why? Because for 20 seconds, the code will be looping here, okay, waiting for the user, if the user wants water or if the user wants to deposit more coins. Because the difference here with respect to the other detections in the beginning is that here the code is waiting for money and the user is not allowed to press the push button. That's why right here it says the push button is disabled. So we're not allowing the user to serve water because he hasn't deposited any coin. But right here he has deposited in these loops. We already detect one coin, And so we wait here. We wait here for a new coin, another coin. And if the user wants to serve water, that might happen. So if he deposits another coin, notice that the code will jump to these locations again. So it'll jump again to the top to keep adding right here, to keep adding more money if he wants. So and once and it'll keep repeating this 20 times, so for 20 seconds. Now let's say the user decides, okay, I've deposited let's say 10 cents and I want water. So if the user presses the push button, RB7 will be equal to 0. The code will jump to this label, water, the water label. And what will happen is that now the code will read port C and will be adding a mask to isolate these 2 bits. And it'll be only reading RC0 through RC5, 6 bits. And RC6 and RC7 will be masked, so will be isolated. Now that we have these from the timer, from the deep switches on port C, we multiply, we transfer this reading to time, to variable time. Now time is multiplied by 1000 to convert it to seconds. And why? Because this instruction only works with milliseconds, so we need to multiply this by 1000. So we multiplied, and it is stored in time seconds, because now the time is given in seconds. So we turn on the water bulb right here, because the water bulb is located in RC7 through a opto-isolated relay. And then we perform this loop for I equal 1 to total, okay? And this pause, make this pause, and the pause is given by the time sec. Okay, so this, notice that pause accepts this variable, accepts not only a constant, it accepts variables. So it'll perform the number of seconds right here. It'll stay there for those amount of seconds. Let's say if he deposited 1 coin and the timer is programmed to, let's say, 10 seconds. So this pause will last 10 seconds. After 10 seconds, you will see that that number there on the display. You want to see it from the beginning, not after the pause. You can display that time in right here or there, but it is good to have it here because after those amount of seconds, the users will see at the end this number, and then for that amount of seconds, you will see that after I is incremented from 1 to total, and total is how many times. In this case, 1 equals or 1 time. 1 time will do this. If he deposits, the user deposits, let's say 10 cents, so this will be equal to 2. So 2 times will be performing this, okay? And once this is finished, depending on the total variable, this loop will finish. Port C7 will be equal to 0, so it'll turn off the bulb and it'll go to repeat, which is the beginning of the code where all ports are clear. So, and right here, of course, we can improve this because we might want to have a timer, a countdown timer, where the user can see the number of seconds decreasing, or he can see the number of seconds increasing. So that's another thing we can add. But this is the heart of the code, and the good thing of this code is that it can serve any amount of water, so it doesn't have to wait until you reach a certain price. Okay, so sometimes people doesn't want a gallon. What if he wants to serve a quarter, 1 liter, 2 liters? So he can do it at any time. Okay, so and another option, another thing we can add to this code is okay, is by doing this. Here, first, the student has an assignment. You're reading this, if you're watching this video. Your assignment will be add code for self-diagnosed when starting to verify the coin sensor's status, okay? The due date is 1 week after this video is posted in your group. And of course, this is the first circuit we saw in the beginning of this video. And okay, this is where we have port C, the 3 types of coins, RB7 where the user presses the push button, RB7, RC7 is the output, and port A is the LCD display. And in the last part of the code that we saw right here, in this part of the code, you don't want to wait this amount of time, and if the user wants to stop the process because maybe his deposit is already full and he wants to stop wasting water, so you can add this code. So this is a second method for the last part where the water label is. So you keep doing the same thing. You read port C, you transfer port C nickel time reading in seconds to time, So this is transferred to this variable, the 6 bits. The water bulb is turned on, and now we make a loop for I equal 1 to total, and here is the next I. So for every 4 there is a next I. So the total, remember the total is, if it is 1 nickel, total is 1. If it is a dime, total is 2. If it is a quarter, total is 5. So that is the number of times, 1, 2, or 5, or depending the amount of money deposited, the amount of coins, that it'll be performing this loop in this purple color. Now we have a nested loop, so we have another loop here where we do for s equal 1 to time, and notice that s we have to declare it as a variable word. So for s equal 1 to time, pause 1000, so make these 1 second pauses, because this is 1000 milliseconds is one second. Okay, I'm just gonna put it here, 1000 milliseconds equal to 1 second. Okay, so those number of seconds will be performing the same pause and from 1 to time. And notice that I'm placing here in red this new instruction, which is asking if the user presses the push button, so user can stop serving water at any time. So every second we are reading that switch just to see if he wants to stop the process. So if he wants to stop the process, it'll go to the beginning where in the RPT is the beginning of the code where all ports are clear, so the water will stop. If he doesn't want to stop it, the loops will continue. So that's another way to do it, and this is a better way to not being trapped in a loop until the loop is finished. So we can stop that loop and go to the beginning. And of course, if this loop ends by itself, when you finish the next I, you can clear that RC7 and go to repeat, and that's it. So anyway, you can select which one of these two you can use, and then you can add that code to here, to this part. Okay, so there are two methods. This is one method where you have to wait right here, and there is no way to ask for if the user wants to stop the process. But you have here another improvement that I said a moment ago is that the LCD display. So we can add more features to the display where the user can see how the money is being deposited. So every time the number of times that these coins are valued, these counters are seen here on the display. Now, another improvement we can do is, instead of watching here or displaying the decimal value of total, we can make another formula where we can convert these to coins, and that way we can display on the LCD the amount, the real amount of money it is being deposited. So that's another option. Okay, this is the code I wanted to explain, and of course this is a circuit we were seeing here. Okay, and where we have 6 bits right here, 6 bits dedicated to read the time, and we can adjust the time from 0 to 63 seconds per nickel. But in real world, it might be even from 6 seconds, 7 seconds per nickel to 20 seconds per nickel. Okay, so that's all for today. Thank you.